Hello, good day, and welcome to another episode of Lab Talk. My name is Megan McDowell, and today's topic is something that I think most of you, if not all of you, will be able to relate to. So we're going to be talking about centrifugation best practices today. I am joined by our resident centrifuge expert, TT Hong, who is a commercial manager here at Thermo Fisher Scientific, and he'll be sharing some best practice tips with you to keep your centrifuges spinning properly.
All right, thank you, Megan. Good morning, everyone. Today we'll talk about centrifugation safety best practices. We'll start off by going over why centrifugation maintenance and care is important. We'll then follow that up by diving into the 6 common causes of centrifuge and rotor failure. Then followed by that, we'll go over specific cleaning, care, and maintenance recommendations. And then finally, we'll do a quick summary of what was presented. So why is centrifugation maintenance and care important? Have any of you ever heard of these phrases before or questions? I've been using my centrifuge for years and never had a problem. Why does my centrifuge move across the bench? We never run the rotors to full speed, so they should last longer, right? I just assumed the rotor was attached properly. The rotor looks fine to me. We don't remove the rotor for cleaning because we've lost that rotor tool thingy. And my favorite, low speed means low concern, right? All too often, I'd say centrifuge users have a cavalier attitude towards centrifuge safety and underestimate what can occur when things don't go right in the lab. So in order to appreciate what a centrifuge can do, let's review Centrifugation 101. Remember that centrifugation is a process that involves the use of the centrifugal force for the separation of mixtures. The amount of force is determined by the speed at which the rotor spins. So let's take a common example used in a lot of R&D labs, general purpose benchtop centrifuge. In this centrifuge type, a researcher would typically use a swinging bucket rotor to run 50 mil conical tubes, let's say 40 of them. And then let's say the G force applied in the run is around 3,500 times G with 1,800 grams of content in each of the 4 buckets. So the question is, what forces are at work here? So to put it in relative terms, the force applied to each bucket is equivalent to 6,300 kilograms, or the same as a fully grown African elephant per bucket. The forces get even greater when you move into super speed or ultra speed centrifugation. Now imagine if that fully grown African elephant gets out of control and goes crashing through your lab. Can you imagine what type of damage this would potentially cause? That's why we stress the importance of maintaining your equipment. Now, aside from the safety aspect, why is it really important, and why would we want to maintain your centrifuge and rotor in general? And that's to allow you to maximize your investment by extending the life of your equipment. And it also increases productivity in the lab by reducing any downtime due to, a centrifuge damage or failure. These are all very important things that will ultimately keep your lab manager happy. Now, let's look at the 6 common causes of centrifuge or rotor failure. First step is consumable failure. Second, incorrect rotor attachment. Third, incorrect balancing. Fourth, bucket overloading. Fifth, rotor fatigue. And 6, corrosion. For step 1, check your consumables. Make sure you're checking all aspects of the consumable, whether it's the tube itself, any seals or closures, O-rings, etc. It's important to look for signs of wear and tear on these tubes, as demonstrated here by Megan. Also, follow your tube manufacturer's recommendations around maximum speed ratings, chemical compatibility, and replacements. If you aren't sure whether you should use a consumable or not, make sure you reach out to the tube manufacturer for further guidance. And as demonstrated here by Megan, there is the seal. She's looking at the O-rings and making sure there's no cracks or wear to that seal, and also in the lid. And then you can visually inspect the outer tube itself. So next, make sure you ensure your rotors are properly installed, and always double check to make sure your rotor is attached securely before running the centrifuge. Megan, will you demonstrate how you would load the rotor? Thank you. As you can see there, Megan did a slight tug on the rotor to make sure that it is properly installed. For our thermoscientific centrifuge users, we have a feature called auto lock that simply just plops down onto the rotor spindle, and you just have to do a simple tug. There are other centrifuges out in the market that require either a tool to tighten, similar to an Allen wrench to tighten down the rotor, or one that you would just have to hand screw in. And in those cases, you make sure that the when you're screwing on that you're following the threads correctly and that it's properly seated. Aside from also ensuring that the rotor is properly attached, you also want to make sure that the buckets on the swing out rotors are correctly placed, cleaned, and lubricated to ensure that the buckets swing freely during centrifugation. If a bucket is stuck and doesn't swing freely, this results in severe imbalance and could cause major damages to your centrifuge and rotor. As Megan is demonstrating, she's seeing that the buckets swing freely and go back to its original place. Another recommendation is to do a quick hand spin of the rotor gently to make sure the buckets move in a free and easy motion before pressing start. Perfect. Now, step 3 is to always balance your rotor with an equivalent opposing load. Megan is demonstrating here what's a correct load and what isn't a correct load. If you have an odd number of samples, we recommend that you fill a sample tube of the same type with water or any type of buffer solution to match the weight of your sample tube. That way you have a similar tube and weight as an opposing load. So right there, that is a correct load. The first was an incorrect load. Now moving on to step 4, we always want to prevent any overloading of your buckets. So pictured here is our SureSpin 632 swing out rotor for our ultra centrifuge. Always reference your centrifuge owner's manual to understand what the maximum load tolerance are at maximum speeds. Remember that if maximum load is exceeded, you must derate or spin at a reduced speed. Reach out to your centrifuge manufacturer for further details on how to properly derate if you are unsure. And specifically for ultra speed swinging bucket rotors used for gradient work, make sure to check the density of the sample against the speed and temperature to prevent point load failures. Fifth cause is metal fatigue. When metal rotors are spun, the high G forces applied to the rotor results in elongation and stresses that weaken the material over time. Take, for example, paperclip when you bend it back and forth. If you keep on bending it back and forth, eventually the metal paperclip will break. Metal rotors will do the same over time after extended use. So it's important to retire a rotor once it has reached the maximum number of runs recommended by the rotor manufacturer. You can usually find these details in the operator's manual. The last common cause of failure is due to corrosion. What we can usually see is surface corrosion due to any extended exposure to moisture or chemicals that you may use to clean your rotors with, and ultimately this weakens the metal material. We also have what we call stress corrosion, which are essentially micro cracks that form deep into the structure of the rotor. These are harder to identify, and you usually find these micro cracks, especially inside the cavities of where you would put the tubes into the rotor. So make sure you are checking for any of these corrosion signs and replace the rotor if needed, if the signs of corrosion are great. So those are the 6 common causes of failure. Now we'll review some cleaning and care recommendations to avoid centrifuge or rotor failures. Clean your rotors, buckets, and accessories using warm water and a neutral detergent with a pH between 6 and 8. Never use any caustic cleaning agents or bleaching solutions that ultimately will cause corrosion to the material of the rotor. Use a soft cloth or brush and nothing with metal bristles to avoid scratching the rotor.
And then finally, after using any cleaning detergent, make sure you are removing any residual detergents or disinfectants with distilled water and a soft cloth. And then finally, make sure you're drying all surfaces of the rotor to prevent any corrosion. In cases of spills in the bowl of the centrifuge, immediately clean up the spill and follow the operator's manual on how to properly disinfect and decontaminate. After you disinfect or decontaminate, rinse the treated areas with water and dry with a soft cloth. After cleaning an aluminum surface of a rotor, make sure to use corrosion protection oil to prevent future corrosion. And don't forget to reapply lubricants to any trunnion rings or bucket shoulders to ensure free movement with your buckets. As a final step to cleaning your rotors, inspect it for damage, wear, and corrosion. Make sure that the protective coating is still there and complete. Look for a plastic crazing, cracking, or fading, which are signs that these components need to be replaced. O-rings are very important to make sure that they aren't cracked or brittle. Use a small amount of vacuum grease to maintain the elasticity of the O-ring. And finally, it's always good practice to do a yearly rotor inspection by a trained professional. So, in summary, proactively inspect and manage consumables. Secure the rotor and buckets correctly. Balance the rotor properly. Never overload the rotor. Prevent corrosion with best lab practices. Retire and replace fatigued rotors. Establish a proactive cleaning schedule. And then finally, get your centrifuge and rotors inspected annually. If you follow all of these tips and tricks, you'll improve your lab experience by preventing any accidents that may result in significant repair costs, lost productivity, or even a loss of your precious samples.